Okay, so this is basically we are calculating the volume using the method that you just created. We are going to use cross-section. So this is called the cross-section method. So we learned 3 methods. One is the disk. Second one, the washer with a ring. The third one is this cross-section one. All right. First question. Actually, we'll skip that one. Okay. The base of a solid S is a circle of radius 1. For this solid, the cross-section, which are the slices, perpendicular to the x-axis are squares. Find the volume of this solid. Okay, so let's draw the circle first. This is the base with a radius of 1. And from this, we are going to we're going to create some squares. Whoa. So sorry about my drawing. So I'm creating some squares that are perpendicular to the x-axis. You don't have to draw the squares. They're not very nice looking. Okay, but basically if you can think it's coming out towards you like a square, just like the ones you created, but the base itself is a circle and squares coming out towards you. Okay, so we need to figure out the volume of this solid. Okay, now the solid has to do with the cross-section you use, right? This one is using a square, so we're going to have to figure out what is the area of that square, and then we're going to add up all those squares. So, this is the square we're going to use. Jonathan, are you with me? Okay, put your iPad away, please. Okay, so basically this square has radius, it's going to be x times x, right? The question is, what is that length? Okay, so what we want to do is remember the equation for a circle. Do you guys remember the equation of a circle with radius r?
X squared plus y squared.
Equals r squared. Okay, so you got to remember that. And then since we are perpendicular to the x-axis, I can't erase this. We're perpendicular to the x-axis. That means this part is called y, and this part is y. Does that make sense? That length, the length of the square is 2y because there's a part above, which is going to be y, and then a part below, that's y. Are you guys okay? These are very quiet. No. Okay, so the circle is going to look like this, right? Or the circle has a radius r, and this part is going to be x, that part is y, right? So then it creates a right triangle. And then that right triangle, you can prove it, but it's going to be x squared plus y squared equals r squared, which creates a circle. So that part, this part is y, which is only half of the length of a square. So then we need 2 of them. So this part is going to be 2y. Are you guys okay? Math looks so dead this morning, like more than usual. This is what happens in first period every day. I just see you second period, so I don't know that. Okay, I see. All right. Okay. Okay. So from this equation, we need to figure out y. Okay. So y squared is equal to r squared minus x squared. That means y is equal to square root of r squared minus x squared. We're just using the positive, obviously. This is all lame, so there is no negative numbers. Okay, so from here, what we want to do is calculate the area of this square, which is 2y squared. So that is 4y squared. Now substitute in y. 4 square root r squared minus x squared squared. Okay, so that is 4 times r squared minus x squared. Now, because we actually have a radius for this circle, right? What is the radius? 1. So then we're actually going to substitute in 1 for the radius. So this is 4 times 1 minus x squared. Okay, up to this point, any questions? You sure? Okay. All right. Now we're going to add up all of the possible amount of squares, cross sections. So we're going to use integral. So the volume is going to be the integral from from -1 to 1, because we're starting from -1 on the, so we're perpendicular to the x-axis, which means we're going to move along the x-axis. So from -1 on the x-axis to +1 on the x-axis. This method, there is no pi because we're not revolving. We're not going to create a circular area. It's just whatever that cross-section is. Okay, so integral from -1 to 1 of 4 times 1 minus x squared dx. Okay, go ahead and figure out the volume. It's all finished. So it is 16/3. Yes? All right, let's try another one. The region R in the plane bounded above by the graph, blah, 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 below by the graph, e to the x, on the left by y-axis, is the base of the solid. For this solid, the cross-section perpendicular to the x-axis are semicircles with diameters extending from f of x to g of x. Find the volume of the solid. This one you need to graph. So you need to use a calculator, because you need to see where those two functions intersect. Okay, for cosine x/2 is something like this, just the cosine graph. And then e to the x is this graph. Okay, a little better. And then on the left is bounded by y-axis. So it's this thing. And we are going to create semicircles along it, with it. So then you need to figure out where do they intersect here, so you eventually have to integrate. Okay, so go ahead and graph it. All right, so what point do they intersect? 1.2? 3 digits.
1.196.
196. Okay, and this is going to be a semicircle, right? So we need to figure out the area of a semicircle. Now, semicircle area is going to be pi r squared over 2, right? So we need to figure out how long is r? How long is r? According to this graph, this is f of x, this is g of x. What is the diameter of this semicircle?
F of x minus g of x over 2.
Diameter. So the diameter is going to be the function on the top, which is f of x, minus the function on the bottom, which is g of x, right? Okay, of course, we still need to find the radius. So we're going to take this and divide by 2. That's going to be r. Okay, so let's write that on the side. R is going to be f of x minus g of x over 2. We're not actually going to calculate with our hands, so we are just going to leave it in f and g. You're going to use the calculator to do pretty much everything. Okay, so area is going to be pi over 2 times f of x minus g of x squared. Yeah? I'm sorry, over 2. So pi r squared over 2 turns out this way. Okay, now volume is going to be adding up all of those semicircles. So we're integrating from where to where?
0 to 1.196.
0 to 1.196 of pi over, let's combine the denominator together. So pi over 4 f of x minus g, wait, I did this wrong, sorry. Pi over 8, yeah. Pi over 8 of f of x minus g of x squared dx. Okay, now use the calculator to find the answer, and since hopefully you already stored it in y1 and y2, you can just recall that and figure out the answer that way. Okay, so the answer is 1.937. Okay, let's do the last kind. This one is a little bit tricky. It's not really tricky, it's just that most people don't remember how to find the area of an equilateral triangle. Okay, same base. Base is a circle with a radius 1. For this solid, cross sections are perpendicular to x-axis, and they are equilateral triangles. Equilateral triangles. So something like that. Find the volume of the solid. Again, we're going to remember that x squared plus y squared is equal to r squared. We have this equilateral triangle. How long is the base? In terms of x and y and all that stuff. 2y. Okay. What is the area of any triangle? What's the area of any triangle?
Base times height over 2.
Yeah, base times height divided by 2. So 1/2 base times height. Okay, we know that the base is 2y. The question is, how high is this one? Which is the tricky part. You gotta do some calculation. Hopefully you do it once and then you remember the trick and then you don't have to keep going back to calculate it. This is an equilateral triangle, so this is 60 degrees, 60 degrees, and 60 degrees. So hopefully you remember how to calculate a triangle with base this way, so you can remember that this is a 30, 60, 90 triangle. So then this part, which is y, is 1. Just think this is 1. It's a 1, 2 square root 3 triangle. So in general, this kind of triangle goes 1, 2, 3, but not 3, square root 3. So then if that part is y, this part is 2y, and then this part is y square root 3. Okay, so from now on, just memorize it. It's a square root 3 of half of your base. Because the equilateral triangles come up a lot, and you don't want to keep going back to this. Okay, so 1/2 base times height. Now you have to substitute, so you have to figure out what y is, but it's the same y as we did in the first example. Do you guys need me to help you continue, or you think you can finish? I think you can finish. Okay, so go ahead and figure out the volume of this solid and let me know when you're done. All right, so the volume is equal to 4 root 3 over 3. Good